Hi everyone, it's Mr. Webster here, and I'm going to walk you through the first trig lesson about right angles and what we call the primary trig ratios for right angles. And that really what they are the ratios of the lengths of sides to one another. So anyway, we're going to walk you through this, and hopefully you might have had a chance to write out the blank note, and then you can kind of follow along with me. If you're trying to keep up with me as we go, you may have to pause the video and write every so often in order to keep up. Okay, so here we go. The first slide. When working with right-angled triangles, it is helpful to name the sides of the triangle. The names are opposite, adjacent, and hypotenuse. So we're going to use those three names, but they're dependent on the perspective of the given angle or the angle that you're working with. So the longest side of the triangle is called the hypotenuse. Here we go. I'm just going to get my pen going. Here we go. Hypotenuse, the hypotenuse of the triangle. And it's easily found since it's always the side that's opposite the right angle. The side across the triangle from a given angle is called the opposite side. And the side that is next to the given angle that you're interested in, which is not the hypotenuse, it's called the adjacent side. Okay, so the adjacent side. All right, so let's look at these two triangles. And let's say we are interested in this angle right here in the triangle, and we now want to label the sides. So we always start by labeling the hypotenuse because it's the side opposite the right angle. So there it is. I'm going to label that side the hypotenuse. Okay. Now, relative to that angle, that theta, the side that's across from it, right there, we're going to label opposite. Okay. And the side that's adjacent to that angle, right here, is adjacent. Now, some of you may say to me, well, Mr. Webster, so the hypotenuse is also adjacent to that angle. It's also touching that angle. But we always label it first as the hypotenuse, and so it gets that name based on the fact that it's across from the right angle. All right, well, let's say there was another triangle, sorry, it's the same triangle, but we're going to look at it from the perspective of a different angle. And I'm going to label this one with this funny symbol. It looks like a fish maybe, but it's called alpha. So relative to that angle, the sides are labeled differently. Well, the first thing we'll label is the hypotenuse, and it's opposite the right angle, so no, it doesn't change. It's always the hypotenuse of this triangle. Okay? However, now, according to this angle right here, right in here, this side is opposite it. So it's called, I would label it opposite. Okay? And this side right here is adjacent. This side is adjacent. So notice that in this triangle, or in these two triangles, sometimes we would call this one opposite right here, and sometimes we would call it adjacent. Okay, so just also know that sometimes we use the capital letter H and the capital letter O and the capital letter A to represent these. Okay, so notice that the hypotenuse never changes. It's always the one opposite the right angle. But depending on which angle we're looking at, if we're looking at this angle right here, this side over here is opposite. And if we're looking, and this one would be adjacent to it. But if we were looking at it from the perspective of alpha here, this angle, this side would be adjacent and this side would be opposite. So the sides can change. Okay. Next, we're going to look at some actual triangles, and we're going to be interested in we're going to look at the ratios of the lengths of the sides. And so I want you to fill in this chart with me, and we're going to look at triangle A and triangle B. So triangle A has a hypotenuse of 31 millimeters. Okay. And sorry, I'm looking, just to be sure, I'm looking at it from the perspective of this angle right here, and I'll call that theta in this case. Okay. For triangle B, I'm going to be looking at it from the perspective of this angle, and I'll call that, I'll call it alpha. Okay, so let's go back to triangle A and look at this. Relative to theta, the hypotenuse is 31 millimeters. It's across from the right angle, so I'd label it as 31 millimeters. Now, the opposite side of theta is 16 millimeters. That's the length of the opposite side, and the adjacent side is 27 millimeters. Okay, so we've written down the lengths of the sides relative to that theta, relative to theta. Okay, well, in trigonometry, we're often interested in the ratios. And so in this case, we're interested in the opposite over the hypotenuse. And so the opposite in this case was 16, the opposite of theta, and the hypotenuse was 31. So that's the ratio. Another name for a ratio is a fraction. And so the fraction is 16 over 31. And if we were to evaluate that from a decimal, we'd get approximately 0.5. Okay, so that's the ratio. And again, if we do the same thing for adjacent over hypotenuse, well, adjacent is 27 and the hypotenuse is 31. And if I were to evaluate that, I'd get approximately 0.9. So 27 divided by 31. And finally, if I do opposite over adjacent, it's going to be 16. That's opposite. And adjacent is 27. And that would be approximately 0.6. Okay, so those are some ratio. Those are some important ratios. Okay, well, let's look at a triangle B. And so I'm going to look at alpha for B. Well, its hypotenuse is 66 millimeters. Its opposite side to alpha is 33 millimeters. And its adjacent side is 57 millimeters. Okay, so that's relative to, there it is, that's the hypotenuse. And here, I'll label them right on here. That's the hypotenuse, that's the opposite, and that's the adjacent. And same thing over here, this is the hypotenuse, this was the adjacent, and this was the opposite. Okay, so again, we could do ratios here. And so opposite over hypotenuse would be 33 over 66. And that one you get exactly 0.5. So interesting, the same ratio. And here you could do adjacent over hypotenuse, so 27 over 66. And again, you get approximately 0.9. And then for opposite over adjacent, it's 33 over 57, and you get approximately 0.6. So interestingly, we get the same ratios. So just know that different triangles could have the same ratios. And what that's telling us is that, in fact, alpha and theta are the same angle. So alpha is equal to theta, and it turns out in this case to be 30 degrees. So obviously these are different sizes of triangles, but their ratios will be the same. Now, let's go to the next slide. And we've come up with special names for these ratios. So these ratios, whenever you have opposite over hypotenuse, we call that ratio, the name we've given to it is sine, S-I-N. And when you have the ratio of the adjacent side over the hypotenuse, it's given the name cos. And if you have the opposite over the adjacent, you have the side tan. And just so you know, those are the short forms. It's actually, and I know that this isn't much of a short form, but it's sine cosine, and tangent. So those are the names of those ratios. And we often use this term SOHCAHTOA. SOHCAHTOA. You may have heard that before. And the reason why they use that, SOHCAHTOA, is that sine of an angle, sine of theta, is opposite over hypotenuse. So you can see they've kind of written it in that order. Cosine of an angle is equal to adjacent over hypotenuse, and tan of the angle is equal to the opposite side over the adjacent side. So SOHCAHTOA. Okay. Now, interestingly, this means that for any right-angled triangle with a 30-degree angle, sine of 30 degrees is going to be equal to 0.5. 0.5, and cos of 30 degrees is approximately 0.9, and tan of 30 degrees is approximately 0.6. So that ratio will always hold when there's a right-angle triangle with an angle of 30 degrees. Okay. Now, calculators are programmed with the trig ratios in them, and you've probably seen these buttons on your calculator, sine, cos, and tan, but really they've got the trig ratios right in them. Now, a couple things, depending on which calculator you're using. A lot of you will be using your cell phone, which is fine, because you may not have a calculator, and so you can use your cell phone, but put it into the scientific mode. I've shown you a couple of calculators here in this slide, but a lot of you are probably using one that looks like this, which is an iPhone. Now, one thing you'll want to do right off the bat is make sure that you're in degrees, okay? So in the bottom right-hand corner, there's a little button that says degrees. Make sure you're in degree mode. Okay. For other calculators, you'd use this button right here, and it should say DEG if you're in degrees. In this one, you'd use the mode button, and again, it'll show a little D. I know it's hard to read there, but it shows a little D that you're in degrees. Okay, so you ensure your calculator's in degrees, and then what you're going to do is type in 30 and press the sign button. Now, I'm going to do it here with my online calculator, and so in this case, if I type in 30 and then click on my sign button, oh, excuse me, I guess this is one where you have to hit the sign button first. So here, I'm going to clear it, and I'm going to hit sign, and then I'm going to type 30. So some calculators you do it one way, some you do it another way, and then I'm going to hit equals. And I notice that it's giving me, oh, I wasn't in degrees. So let me do this one more time. I'm going to clear it, and I am going to make sure I'm in degrees. Here we go, one last time. I hit sign, I hit 30, and I hit equals. There it is. So it gives me 0.5. Let me go back, and sure enough, I can put a 30 in here. Okay, I'm going to do the same thing again. I'll do it correctly this time for cos. And so I'll go back to my calculator. I am going to clear it. I'm in degrees. I hit cos. I hit 30. And I hit equals, oh, 0.866. So here we go. I do, sorry, I did that incorrectly. It should say 0.5, my apologies. And here it says 0.866. And finally, I'll do it again for tan. And what I'll do is I'll clear. I'll hit tan, I'll put in my 30 and hit equals, and 0.577. Okay, so 0.577. So notice that this is approximately equal to 0.9, and this is approximately equal to 0.6, and so that's what we'd found out. Okay, now the next slide. you can actually use your calculator to go backwards as well. So to calculate an angle if you know the ratio. So in this case, again, make sure your calculator is in the degree mode. Now in this case, you're going to do what's called the second function or the inverse. Now I'll show it to you on a couple calculators. So again, in this case, you'd be hitting the second function and then hitting sine. Here, you'd use the shift button and then hit sine. And in the case of your iPhone, if you're using an iPhone, you'd hit second and then hit sine to do the opposite, to kind of do the opposite operation. So let me show you. So in this case, we want to do, if we knew that the trig ratio was 0.5 and we wanted to know the angle. So what we're going to do is hit second and then sine and then see what it says. Well, let me go to my online calculator. Here we go. And I'm going to clear it. And here we go. In this case, it's I hit inverse. Inverse is like hitting second. So I'm going to go inverse sine. And then I'm going to type in 0.5 and hit equals. And it gives me the answer of 30. It gives me the answer it's kind of doing the opposite. And so for you guys, if you'd hit second and then sine and typed in 30 into your iPhone, you'd get a 30 degrees. And same thing here, I'll try it again for this one, is that if you type in I'm going to clear and I'm going to go inverse or second cos and I'll type in 0.866, that's the ratio, and I hit equals, gives me roughly 30 degrees. And so you'd put that in here and you'd get 30 degrees. And obviously if we do it again for 10, we get the same thing. That's the ratio that gives you the that shows you the angle. Okay, I'm going to try a few homework questions with you now, and then I'm not going to do them all, but I'll just kind of get you going, and then you guys can finish them off. But these are the homework questions assigned for today. So, in number 1, it says, which side is opposite angle A? So look at this. They're asking you, there's angle A, and they're saying which side is opposite. So the opposite side is CB or BC. I'll just label it CB. So it's that side right there. Okay, you can finish B and C on your own. Okay. Number 2 says determine the value of each ratio to 4 decimal places. So for this one, you're going to need your calculator. And so we're interested in determining what is the trig ratio for 10 of 34. Okay, so what I'll do is I'll go to my online calculator. Here we go. And I am going to clear it. And I'm going to type in 10, 34 equals. And it gives me 0.6745. Okay, so I can write that into my 0.6745. I think I remembered that correctly. Okay, so you can use a calculator to determine each ratio, and they asked me for 4 decimal places, so that's what I did. For 3, it says determine the angle. So this is where we have to kind of do the opposite thing. So I'm going to do this one. So we're told that sine of theta is 0.5. So remember, if I just want the angle, we're going to do what's called the inverse, or the second inverse. And they put this little negative one there to show that they're doing the inverse of 0.5. Okay, so again, I'll go to my online calculator to show you. You guys can use your cell phones. Okay, I'm going to clear it. And so first of all, I'm going to go inverse sine, and I'm going to type in 0.5. That's what they've asked me to do. And I hit equals. And sure enough, we already knew that one. It's 30 degrees. So I'm going to type in 30 degrees. Okay, and I would round that to the nearest degree. So you're going to have to do that same thing. like here, I'll just show you for B. For B, you're going to have to go to your calculator and go, well, theta is going to be equal to the inverse tan of 1. So here, let's finish this one, and I can let you do C and D on your own. So we would go to our online calculator, and I'm going to go, I'll clear it, and I'll go inverse tan. So there it is, the second function tan, and I'm going to hit 1, and I'm going to hit equals. Oh, and it's 45 degrees. So I can go back, and that's equal to 45 degrees. Okay, I'd like you to finish C and D. Let's look at a couple more here. So number 5, it says, determine the ratio and then write it as a decimal. All right, so let's do A together. So it says sine of angle C. So here's angle C right here. So sine of C, well, sine of C, remember sine, it's so it's SOH, it's opposite over hypotenuse. So relative to the angle C, this would be the hypotenuse, and this would be the opposite. So I'm going to write it as 8 over 17. And then I'm going to go to my calculator and type that in, 8 divided by 17. Okay, I'll just clear this, and I'm going to go 8 divided by 17 equals, and I get 0.4705. They wanted 4 decimal places, so I'll round the 5 up to a 6, and so it's 0.4706. 0.4706. Okay, so that's A done. So they want you to do that. So for B, you'll do the cos of C. So always look at the side, or sorry, look at the angle, and then decide what is opposite and what is hypotenuse, because it's going to change. The hypotenuse will always remain as this side, but the opposite and adjacent will change depending on whether you're looking at A or B or C. Okay, so finish that one off. For 8, it says solve for x in each case. Well, here's what we're going to do, and let me work on A with you. So for A, it says if you know that cos of 45 is equal to x over 6. Okay, well, so when we're working with polynomials, equations, my apologies. When we're working with equations, we know that if we want to get the unknown, in this case the x by itself, you have to get rid of the number that's with it. So right now, it's divided by 6. The opposite of dividing is to multiply. So we're going to multiply this side by 6. But whatever we do to one side, we've got to do to the other. So I'm going to multiply this side by 6. Okay, so x is going to be equal to 6 times cos of 45. Well, I'm going to do part of this already. I'm going to go to my calculator and figure out what cos of the angle 45 is. And so I'm going to go to my calculator, and I'm going to type in there, I'm going to clear it. I'm going to type in cos of 45, and I'm going to hit equals. And it's 0.7071. So I'm going to write that in here. 0.7071. And so now I just have to do 6 times that to get what x is. So you're just rearranging to get the unknown by itself. So 6 times 0.7071, I'll go back to my calculator. And actually, I've got it right in here, so I'll just do times 6 equals 4.242. And it says to 1 decimal place, so 4.2. The number beside it would have been a 4, so I don't round that up. So x is equal to 4. Let me show you one where the unknown is on the bottom. So let's do f as well here. I'll do f with you. And so for f, it says sine of 45 is equal to 10 over x. So we want to solve for x. And so
what I want to do here is get x by itself, but I also want x by itself on the top. And right now it's on the bottom of the fraction. So I want to change that. So what I'm going to do is I'm going to multiply this side by x, and I'm going to multiply this side by x. And I'll show you why I did that. Is that now I can, if you do x over x, I can get rid of that. It goes to 1. And then I have x up here in the top, in the numerator. But I still want x by itself, so I'm going to divide this side by sine of 45, and I divide the other side. Whatever you do to one side, you got to do to the other side, so divide the other side. So you finally get left with an expression that looks like this. X equals 10 over sine of 45. And all I did was to get x by itself was to rearrange like that. And so it'll be very similar anytime the unknown is on the bottom. So here we go. I'm going to do 10 divided by, well, let me figure out what sine of 45 is. So I'll quickly go to my online calculator. Here we go. Oh, and I've forgotten already which one, what I was doing there. It's 10 divided, or sine of 45. So here we go. I'm going to clear it, and I'll do sine of 45 equals, and it's 0.7071. So here we go. It's 0.7071. And so I'm going to do 10 divided by 0.7071. So here we go. 10 divided by 0.7071, and I get 14.14, and they want it to one decimal place, so 14.1. Here we go, 14.1. So that's what you're doing in that question. I'd like you to finish some more of those off and practice those. Okay. For number 10, it says determine the length of x. Now, and then it says state the primary trig ratios. So one thing that we want to make sure that we don't forget about is that we always have Pythagorean theorem. This is a right-angled triangle, and so we know that the two shorter sides, a squared plus b squared, will equal the longer side. And so in this case, our x we can find by going 8 squared plus 15 squared is equal to c squared. And then we can get rid of the squared by taking the square root of both sides. So let's solve for, in this case, it'll be x is our hypotenuse. Make sure that you always put the hypotenuse on its own side. You'll have to, for b, it's going to be a little bit different. But here we go, 8 squared plus 15 squared, and then square root. Let's go to our calculator. Here we go, 8. 8, and I think I'll use this button on this calculator. 8 squared plus 15 squared equals 289, and then square root the answer, and I get 17. Okay, so let me go back, and so I got an answer of 17. Oops, I'm having some difficulties there. 17. Okay, and now they want you to I'll put the 17 up here, and they want you to state the trig ratios. So here we go. Sine of theta is equal to opposite over hypotenuse. That's so. So opposite of theta is 15. It's opposite theta, and the hypotenuse is 17. Cos of theta is adjacent over hypotenuse. That's the ca. And so it's adjacent is 8 over 17, because the 8 is adjacent to the theta. And finally, tan of theta is opposite over adjacent. It's TOA. And so opposite was 15 and adjacent was 8. Okay? And so they just want you to state the ratios. So can you guys do it for number 10? Finally, for 12, it says determine the measure of the angle of theta to one decimal place. So here we go. Remember that
if I know that sine of theta is 2 over 5, which I know is 0.4, it's 4 over 10. And so in order to get the angle, what we do is we would do the inverse. Remember we were doing that. Sine -1 of 0.4. Let's go to our calculator. And we're going to do the inverse. So on mine, I hit inverse. On your, if you're using a cell phone, you'd hit second. I'd go inverse of sine, I think. Let me just look at that. Inverse of sine, yes. Inverse of sine of 0.4 equals 23.57. And I think they said to go to one decimal place, so we'll say 23.6 degrees. Here we go. 23.6 degrees. All right, there you go. Can you try those other homework questions? And you guys take care.